fluid coding and AI here. Qwopus3.5 Coder sounds like the kind of local model developers want, small enough to run locally, tuned for coding, and positioned around tool use. But the benchmark receipts tell a more cautious story. The question is not whether this model can produce useful text in a chat box. The question is whether a local 9B coder model can survive the kind of evaluator-driven work that matters for coding agents: editing code, returning structured output, handling tool loops, and not timing out when the task gets awkward. By the end, the useful answer is not hype or dismissal. It is where this run says to be careful. The model page for Qwopus3.5 coder describes it as a fine-tuned coder model based on Qwopus3.5 version 3.5. The card says it is optimized for agentic coding, tool calling, and logical reasoning. Hugging Face also lists a Qwen3.5 lineage, while the page reports a model size of 10B parameters. That is the promise side of the story. The local angle matters because GGUF packages model metadata, tokenizer information, and weights into a runtime-friendly file for llama.cpp-style tools. LM Studio then gives developers a familiar local server route, including OpenAI-compatible APIs. In this benchmark, the model was reached through LM Studio at a local endpoint. That is close to how many people wire local models into experiments, editors, and agents. Tool calling is also not magic. LM Studio's docs describe the basic loop. The model requests a function call, your code executes that function, and the result is returned to the model. So a tool-tuned model still depends on instruction format, schemas, client behavior, and the benchmark harness. If any part of that loop is mismatched, the result can look much worse than the model card promised. Now the actual run. The provider was LM Studio. The model ID was Qwopus3.5 coder. The benchmark suite was LLMBench, All Benchmark Suites, with 93 handled cases. The report records the endpoint, model ID, suite, output path, and scores. It does not record the exact quantization file, hardware, context length, sampling settings, system instructions, or LM Studio runtime version. The headline was 600 points out of 2,073, or 30.87%. Status counts were 26 passed, 63 failed, and 4 error cases. Coding dominated the point total, with 21 cases worth 2,001 possible points. The non-coding sections each had 12 cases on a much smaller scale. So the chart needs one big warning label. This overall score is mostly a coding task score. Inside coding, there was one clean full pass. The easy date range validator scored 100 out of 100. The JSON config merger was a stronger partial at 80 out of 100, but the hard cases were rough. Job queue, notes permissions, order pricing, and webhook receiver each scored 15 out of 100. The showing scheduler scored 0. Very hard coding tasks mostly landed between 15 and 45 out of 100, except for one error case. The error cases matter because they resemble failures a developer would feel in a real local agent workflow. The easy CLI word counter timed out after 1800 seconds. 2 medium coding cases and 1 very hard coding case hit evaluator JSON problems, where the judge did not return a JSON object. That does not prove the model can never handle structured output. It does say this run had serious reliability problems under the harness. The non-coding sections were not the headline scoring engine, but they still add context. Source research scored 6 out of 12. Quantitative reasoning, writing editing, planning operations, and safety policy each scored 4 out of 12. Data interpretation scored 3 out of 12. For a coding agent, these categories matter because real development work is not only code generation. It includes reading requirements, evaluating trade-offs, following constraints, and returning the right answer shape. The fair read is narrow. This benchmark does not globally invalidate Qwopus3.5 coder, and it does not test every instruction format, quantization, runtime, or hardware setup. The MTP GGUF model page even reports its own 30-question comparison with better author-reported accuracy and throughput, while also noting quality issues such as repetition and truncation. Treat that as model card evidence, not independent proof. The safest claim is simple. In this LM Studio LLMBench run, the model struggled. My practical verdict: do not treat this as a drop-in replacement for a strong cloud coding model or a high-trust autonomous coding agent. If you try it locally, start with bounded acceptance tests. Ask it to edit one file, return valid JSON, call a simple tool, pass a small test suite, and recover from bad input. For low-risk local experiments, it may still be worth testing. For multi-step production work, keep a stronger fallback. If this benchmark helped you think more clearly about local coder models, like the video and subscribe to Fluid Coding and AI. I will keep testing the gap between model card promises and real developer workflows.